Hello students, welcome back. Previously we discussed factorization problems, especially the factorization of non-monic quadratic trinomial. Let's review that briefly. Begin with multiplying the first and last numbers. 5 times -4 is -20. And then factors of -20 that add up to the middle number. In this case, positive 10 times -2 will do. Remember, this is multiplication, and they add up to this. Now fill out the puzzle. Horizontally, vertically, all multiplications. And the very first column is always positive as long as the very first is positive. Fill it out, and then we go with the cross multiplication. 5 -2, 1 +2. So 5x minus 2, 1x plus 2. That's how you do the factorization. Once the factorization is done, you can set it equal to 0 so that the first factor is equal to 0 or the second factor is equal to 0. Because something times another is 0, that means one of them has to be 0. There's no way you multiply two non-zero numbers to get a 0. So solving those, we get 2/5 or -2. Beware the sign change. If this is negative, then we have positive. If this is positive, then we have negative. That's how you solve a quadratic equation through factorization method. Monic case, which is easy. Non-monic case, which is far more difficult. And I talked about tic-tac-toe method, but there are many other methods. If you prefer any one of those, and if you feel comfortable with it, go ahead and do that. If you had been using some other method, but frequently you're making mistakes or it just didn't click, and if you want to learn a new trick, okay, try this tic-tac-toe method, because that's the only one I would spend enough time to teach. After all, this all belongs to the intermediate algebra, or actually before that. Now, what about higher degree equations? Fourth power, that too is fourth power. I mean, look at the coefficients. So look at this and this. 5, 8, -4. So same coefficients. So they must be related. Yes, that's true. But here we have fourth power, third power, and second power. Here we have fourth power, second power, and zeroth power. Can we recycle what we did for quadratic trinomial for the higher degree trinomial equation? The answer is yes, we can, but we have to use two different methods. For something like this, where we have some common extra whatever power, this common factor to take out, versus no such thing here. The second case is much harder. Let's go to the first case. Take the greatest common factor out. GCF, the greatest common factor. Take x squared out. Then what's left is second power, first power, and zero power. And what do you end up with? The very same equation we saw before. So either x squared is equal to 0, yeah, or solving this using the same thing we did before, we get 5x minus 2 times x plus 2 equal to 0. So we have three factors, so we have three solutions. X equal to 0, which comes from this common factor, GCF, and the other two come from something we did before. All right? How do we factor this into this? Well, we did it in the previous problem. And of course, if I give you a different set of problem, then you can set up different tic-tac-toe and get that done. In any case, you get it through the GCF, the greatest common factor. How do you know if this is a GCF problem? The last number. X squared is there, and the third power, fourth power. Take x squared out, and what's left is quadratic. This method Usually students don't make much mistake here. I haven't seen a lot of mistakes here. Now, every single semester, I see a lot of mistakes from here. Students try to use GCF method here, even though that's impossible. There's no GCF here. There's nothing to take out from the last term here. So GCF method doesn't work. How do we work it out? If we put y equals to x squared, then this whole thing becomes this is x squared and this is 8x squared minus 4. So this whole thing becomes 5y squared plus 8y minus 4 equal to 0. Basically the same as this. So what we can do is to factor it with respect to y. 5 minus 2, y plus 2. Remember this? Therefore, 5x squared minus 2, x squared plus 2. You can factor it with respect to x squared. Look at the final expression there. So, what did you do with this one? Well, you see the tic-tac-toe method, and then you ended up with this. 5x minus 2, x plus 2. But look at this. This is x squared squared, x squared. So after factoring with respect to x squared, you get this factorization. 5 squared minus 2 times x squared plus 2. That's what it ends up with. We get that. We're not done yet. We just did a factorization. We have to set the first factor equal to 0 and the second factor equal to 0. Let's set the first factor equal to 0. What do you get? 5x squared minus 2 is equal to 0. 5x squared is equal to 2. X squared is 2/5. So far so good. And then what? We take the square root. Plus or minus square root of 2/5. That's the answer. Now, what if you have this letter, x squared is equal to -2, and at this point, you can say no answer, no real solution, then go ahead. But if you want to find out a complex root, here we go. Take the square root of 2i. But of course, this kind of thing is totally irrelevant for this course. In algebra, we did something like this because you were just learning complex numbers there. But here in applied calculus, we never use complex numbers. So never mind about this. Whenever you have x squared equal to negative something, then stop there. No solution there. Just move on to the other factor. And x squared is certain thing, then plus or minus square root, and that's it. And don't be intimidated by square root expression. That can be complicated. Okay, so much for subsection 2.1.